See this and all. Now we are doing calculus. We are doing calculus. See this and all. Okay, we are doing calculus. We are doing calculus. So under this calculus, limits, then differentiation, and integration there. Limits, differentiation, and integration there. So for now, I'm going to start differentiation part. For this part already done. Differentiation, here target question will be part B pure paper. Part B pure paper. Question number 14. Question number 14. Definitely that question will be there. Then for this part 15 mark, and there's part A question as well. Part A question 2.5 mark. Then under this differentiation part, we have 17.5 mark. Definitely 17.5 mark for your A-level paper. Then full question and part A question. Very important one, differentiation. Then for integration also same, we have part B question, question number 15 and part A question there. Then all together there will be 17.5 mark. 17.5 mark. Yes, 17.5. So for limits, directly we have part A question 2.5 and indirectly we have for question number 12 and question number 14 relation. Question number 12 and question number 14 relation. For question number 12, again usually we have 2% mark. Question number 12. Then here 35 and 39.5 under calculus part. Okay. Full paper 39.5 marks for calculus part. Very important lesson. Then calculus, especially limits, differentiation and integration. Limits, differentiation and integration. So you have to learn after the A levels as well. Then very important part, calculus, limits and differentiation. Limits and differentiation. So see this concept first. Consider variation between two variables x and y. We denote by a function, no? We denote by a function, y equal fx. Then x equal variable, y we call variable. Then usually x equal independent variable, y we call dependent variable. Then as variation with x, y varies. With x, y varies, no? With x, y varies. Therefore, when you consider this type, so we can sketch graph. So it goes like this, no? There can be this type of graphs. So when you consider this type of graphs, so there will be special points. We call here minimum, here maximum, and here we call point of inflection, and here point of inflections. Likewise, there can be special type relations, special type points. So when you consider this graph, when you consider this one, as x increasing, here x increasing, no? As x increasing, y also increasing up to this level, increasing. Then it goes to decreasing, no? Increasing and decreasing. Then by calculus, we can check that increasing functions and decreasing function ranges. Also, so here when you consider a straight line, then you can say gradient, no? Gradient. we can discuss gradient. But for curve, it is somewhat difficult to analyze gradient. So when you consider this point, if you sketch a tangent, then gradient 0. When you consider this point, if you need to find gradient at that point, so you have to sketch tangent here, then thereafter consider tan value of this angle. No? Likewise, so when you consider this type of relations, we have to consider gradient. No? Gradient. Then to get gradient, we use calculus. Differentiation especially. Differentiation. Then there can be graph like this. Here we call concave up. Concave up. Here there can be graph like this. We say concave down. Here concave up, concave down. Concavity. Concavity also can be obtained by differentiation. Differentiation. Then the fundamentals of differentiation comes with limits. Fundamentals of differentiation comes with limits. Limits. Okay. Then without limits we can't do differentiation. Without limits we can't do differentiation. But anyway, so we use some first principles to derive differentiation techniques, differentiation rules. Thereafter we can apply that relations after that. Okay. Therefore, limits are important to identify differentiation, but without limit again we can go further. Without limit also we can go further. Okay. Let's see this one. Before that, write down topic differentiation. Topic differentiation. Write down a function is a special relation in mathematics. A function is a special relation in mathematics. There can be single variable functions, or multivariable functions, And also, as according to the relation type, further functions can be classified. As according to the relation type, further functions can be classified. With star mark, write down. For functions, there's graphical representation. For function, there's graphical representation. With these graphs, there are some special shapes. For these graphs, there are some special shapes. Okay. Now you sketch with me. Sketch with me. Okay. Here we call local maximum. Here we say local minimum. Here we say increasing inflection. Here we say decreasing inflection. Decreasing inflection. Local maximum, local minimum, increasing inflection, decreasing inflection. These are some special points. Okay. Now at this point you sketch a tangent. At this point you sketch a tangent. Sketch tangent. Sketch tangent. Say here tangent parallel to the x-axis. Here tangent parallel to the x-axis. So here this case that is very special. Tangent parallel to the x-axis, that means gradient 0. Gradient we say m 0. Gradient 0. Okay. Now you go here, sketch this type. Here these are increasing functions. Increasing functions. So as x increasing, y also increasing. That's we call increasing function. As x increasing, y increasing, no? Increasing function. Then for these cases, here acute angle relations, no? Tangents are acute angle. Then gradient positive. Here we discuss about gradient. Here especially we say concave up. Concave up. Here we say concave down. Concave down. Concave up, concave down. Sketch with me. These are special shapes. Huh? You consider here this type relations. Take these type relations. We say decreasing functions. Here as x increasing, y decreasing. As x increasing, y decreasing. Therefore here obtuse angle relations. Tangents are obtuse angle, make obtuse angle, no? Therefore gradient negative. Here we say down, concave down. Here we say concave up. This one concave up. Concave down. Concave up and concave down. sketch them. This is very simple lesson, na? Okay. Okay, then check this all, check this and all. Here another case. Here x-axis, y-axis, there can be function like this. It's gonna touch a horizontal line. It's gonna touch a horizontal line. Here x-axis, y-axis, it's gonna touch vertical line and horizontal line both. Here this is we call vertical asymptote. And here we say horizontal asymptote. Horizontal asymptotes. Vertical asymptote, horizontal asymptote. So anyway, that touch axis parallel to x-axis or any axis parallel to y-axis. So if we touch any axis parallel to y-axis, we say it is vertical asymptote. If we touch any axis parallel to x-axis, we say that is horizontal asymptote. These are special shapes. Okay. Better to sketch. Okay. When you consider these all relations, we mainly focus about gradient of the tangent, no? Gradient of the tangent. Here to check this one, you have to sketch tangent and check gradient. You sketch tangent, check gradient. Sketch tangent, check gradient. Here gradient fixed value. But for this case, gradient variable, no? Variable gradient. Here fixed value. Then here this case, we have to sketch tangent and check gradient. Gradient 0. Sketch tangent, check gradient. Gradient 0. Then for these points, gradient 0. And for these cases, gradient positive. Gradient positive. And when you consider here, gradient negative fixed value, here gradient negative and it decreasing. So here gradient negative and increasing. Value increasing, no? Then anyway, we have to check gradients. So when you consider asymptotes, again you have to check gradients. See this? So at this point, when you sketch tangent, gradient 0. At this point, when you sketch tangent, gradient positive, then gradient decreasing. At this point, gradient 0. Gradient 0 at the infinity, gradient goes to 0. So when you consider this point, gradient infinity, gradient negative. Here 0. At infinity 0. At this point, gradient infinity. Likewise, we have to check gradient, no? then gradient act many important role in a graph. Therefore, to analyze that gradient, we use calculus, differentiation especially. Okay? By limits, we can analyze this tendency. By limits, we can analyze this tendency. Horizontal asymptote and vertical asymptote also we can analyze using limits. And also we can analyze by using differentiation. Okay. Put star mark and write down. By considering all the above special points, the analysis can be done by the gradient. The analysis can be done by gradient. Here this gradient can be a fixed value. Here this gradient can be a fixed value or can be a variable as x varies. Here this gradient relations can be analyzed by principles of differentiation. Okay. Okay, now see this one. You consider a function. See this concept, x-axis, y-axis. Here a function. Okay. Then let a graph like this. Consider this graph. So you take point somewhere here, say P. Then corresponding x value x, corresponding y value y. Okay, say this on a general point. So along this x-axis, I'm going to give a small increment. So if this value 1 plus 1, 11. Sorry, 1 plus 1, 2, like that, likewise. Okay, here 10 plus 0.1, 10.1, likewise small increment. Okay. So when you consider variable x, this increment we say delta x, we denote by delta x. Here not 8, it is delta x. Then this point will be x plus delta x, no? X plus delta x. Then corresponding point we say P, point we say Q. Then here x plus delta x, then you say y. Here this increment, say delta y. Then here y plus delta y. Point will be y plus delta y. Okay. Then say this function fx. Say this function fx. Function f. Consider this geometry. Okay. Here general point along x-axis I will give small increment delta x, small increment delta x. Then corresponding that y will be increased, then increment in y, delta y, delta y. Now when you sketch a chord like this, consider this chord, take this angle theta, take this angle theta. Then gradient of this chord given by tan theta, no? Gradient of this chord given by tan theta. So let's denote that one by MPQ. MPQ equal tan theta. MPQ equal tan theta. Gradient of PQ. PQ. Now I'm going to do this, say here tan theta value equal delta y divided by delta x, no? Here delta y and here delta x. Delta y divided by delta x. Delta y divided by delta x. So when you consider the function f, then you can say y equal fx, no? Y equal fx. Then x image will be fx. X image will be fx. Then x plus delta x image will be y plus delta y. X plus delta x image will be y plus delta y. Therefore, y plus delta y equal f, then x plus delta x. You have to substitute instead of x plus delta x, then corresponding y value will be y plus delta y. Here second relation, here function, okay, fx. Here not just a bracket, here function notation, fx plus delta x. You can't expand fx plus f delta x, okay, is a function notation. Now when you subtract these two, when you subtract 2 minus 1, then y plus delta y minus y equal fx plus delta x, fx plus delta x minus fx. Then delta y equal fx plus delta x minus fx. Okay. Then I'll write this one further. Here delta y equal, take this one, fx plus delta x minus fx divided by delta x. Delta x. That is our gradient now. Gradient. Now I'm going to do this one. Here delta x, some value there, no? So if I decrease this delta x value, it goes like this. It goes like this. Here now delta x here. Then you move this way. Therefore, this Q point move along this curve towards P, no? So as delta x goes to 0, as delta x goes to 0, Q point goes towards P. Okay. Then when Q here, now here the chord. When Q here, now here the chord. When Q here, here the chord. When Q here, the chord is like this. When delta x 0, then chord we say the tangent drawn at P. Tangent drawn at P. Take this angle alpha. Take this angle alpha. Then tangent at P. Okay, first do up that. First sketch this diagram. Before that, subtopic, write subtopic. First principle theorem on differentiation. First principle theorem on differentiation. First principle relation on differentiation. Okay, write small note. Write small note. Let y equal fx. Let y equal fx be a real function. Let y equal fx be a real function as the given figure. And point P on the curve, within bracket x comma y. within bracket x comma y is a variable point. Is a variable point. When a small increment given, when a small increment given to x as delta x, the corresponding x coordinate will be x plus delta x. The corresponding x coordinate will be x plus delta x. Then the increment in y is delta y. Okay. Now you sketch this one very carefully. Here theta angle PQ chord inclination or slope. Here alpha value, you have to sketch tangent at P, that is alpha. Here x, increment delta x, then coordinate x plus delta x. Here coordinate y, corresponding increment delta y, then coordinate y plus delta y. First sketch, don't write all the others, just sketch function. Just sketch, that's enough. Then you write starting here. First write gradient of PQ and thereafter you go to here. Then finally replace delta y fx plus delta x minus fx over delta x. Do up to that. function fx, y equal fx, here x corresponding image, y equal fx, x plus delta x corresponding image, y plus delta y, then x plus delta x equal y plus delta y. When you subtract, you can subject delta y, that is fx plus delta x minus fx. Here you can't expand, general way you can't expand for fx. Here no further simplification. Without knowing function we can't do. Therefore anyway, delta y equal now fx plus delta x minus fx, fx plus delta x minus fx. Then tan theta, delta y over delta x, then delta y equal fx plus delta x minus fx over delta x. Get that relation, huh? Here this differentiation concept new to you. First principle somewhat hard to analyze, but anyway differentiation very simple. Later applications will be very simple. Take 1 minute further. Now further you see, delta y divided by delta x equal fx plus delta x minus fx divided by delta x. You analyze delta x is a single term. Delta x is a single term. That is not x times delta x. It is a single term. Okay? Delta x is a single term. Then this is not delta times y. Delta times y. You can't cancel delta. Then fx plus delta x can't expand like just bracket. It has different meaning. Okay. Now I'm going to do this one. Limit delta x goes to 0, delta y divided by delta x. You put limit delta x goes to 0, fx plus delta x minus fx divided by delta x. So when you consider that limit, so let's see what will happen as delta x goes to 0, I mean here this point goes towards this point, this one. So when delta x goes to 0, it close to P, no? Then PQ chord will be tangent drawn at P, no? Tangent drawn at P. Okay. Then you say here onwards, limit delta x goes to 0, delta y over delta x, gradient of the tangent drawn at P. Gradient of the tangent drawn at P. So when delta x goes to 0, then that chord changes to tangent at P. Then here onwards, we denote this one by dy by dx. Here onwards, we denote this full thing dy by dx. This is not division, but we write like division, dy by dx. This is not division, but we write like division. Dy by dx means this full idea. And for this, here this idea we say f dash x. F dash x. Here we say derivative derivative of y with respect to x. Here dy over dx means derivative of y with respect to x. Derivative of y with respect to x. That represent gradient of the tangent drawn at P. Okay, gradient of the tangent drawn at P. That is we call derivative, and this process we call differentiation. This process we call differentiation. Then final result will be derivative. Final result will be derivative. Therefore, derivative represent gradient of the tangent. Gradient of the tangent. Okay. Here dy by dx, that is tan alpha. We say tan alpha value. Then derivative represent dy by dx represent gradient of the tangent drawn to the curve at P. Drawn to the curve at P. Okay, write that one as well. That is we call differentiation. This process we call differentiation. Final result will be derivative. Derivative represent gradient. That is a general gradient. Okay. If you have doubt on this concept, see this one. Here consider this curve. Consider this curve. Consider this curve. Here the point P, here the point Q, here increment delta x, here increment delta y. Then here the chord theta. That tan theta delta y over delta x. That is equal delta y over delta x. Delta y over delta x. Then tan theta represent gradient of the chord. Tan theta represent gradient of the chord. Okay, gradient of the chord. Okay, now limit delta x goes to 0. Delta x goes to 0, delta y over delta x value. See this full value. Let's see what will happen. Nah? See this one clearly. So when delta x goes to 0 mean here it has some value here. No? So I'm going to decrease that one. So if delta x some small value, then q point goes to here. So when come delta x here, q point here. Now here pq chord, then pq chord. Then delta x goes to 0 mean it's so close to this point, no? Therefore we can't see that chord, we can see only tangent here. So at this point we can see only tangent at delta x goes 0. Take this angle alpha. Okay. Then here this represent tan alpha value, not tan theta further. That represent tan alpha value. Okay. Then that one we call dy over dx. Dy by dx. Okay, dy by dx. That is equal differentiation. That process is called differentiation. Result will be derivative. Result will be derivative. Anyway, by the differentiation, we're going to find gradient. We're going to find gradient. That's it. Okay, with star mark write down. With star mark write down. Dy over dx, dy by dx. Here dy by dx represent derivative of y with respect to x. Dy over dx represent derivative of y with respect to x. It is a single term. It is a single term. It is a single term, not a division. It is a single term, not a division. That represent gradient of the tangent, that represent gradient of the tangent drawn to the curve at a general point P. At a general point P. Next star mark. The above process is differentiation. The above process is differentiation. The above process is differentiation. Okay. You better to note this one again. Then dy over dx, not a division, but we say that is dy by dx. We say that is dy by dx, but that is not a division, but it has some properties on division. It has some properties, not all. Like there are some properties. Okay, with star mark write down, by the above process, derivatives can be obtained. By the above process, derivatives can be obtained. Next star mark, there can be one-side derivatives. There can be one-side derivatives. But here only we consider, only about differentiable functions. We consider only about differentiable function. Then one-side derivatives are neglected. One-side derivatives are neglected. Okay. Now, like limits, you have one-side derivatives, but we don't discuss about for now. Okay. Write down this one. By first principle theorem, find derivatives of the following functions. Find derivatives of the following functions. Derivatives of the following functions. Okay. I'll do one, then you can do further. Here, take this example. Here y equal x. Here y equal x. Then differentiation. For differentiation, we need limit delta x goes to 0, delta y divided by delta x. So we need delta y divided by delta x, limit delta x goes to 0. Then here if x limit delta x goes to 0, fx plus delta x minus fx divided by delta x, no? Minus fx divided by delta x. That is the definition. Okay. Limit delta x goes to 0, delta y over delta x, limit delta x goes to 0, fx plus delta x minus fx over delta x. That is the definition. Okay. Then for this part we say dy by dx. Now let's do this way. Let a small increment delta x is given to x. Then the corresponding increment in y is delta y. Okay. You give small increment for delta x, for x. Then increment in y, delta y. Okay, then here you write y plus delta y. Then give a small increment x plus delta x. Yes, second relation. So that means when you substitute x for x plus delta x for x, then corresponding increment in y plus delta y. Okay, see first example. See first example, then you can do further. Now you subtract 2 minus 1. Then y plus delta y minus y right side x plus delta x minus x. Simplify. Delta y equal delta x. Delta y equal delta x now. So for differentiation, we need the delta y over delta x. Now you divide this one by delta x. I'll go to here. Then delta y over delta x, we say 1. Then delta y over delta x, we say 1. Now you put limit, delta x goes to 0. Limit, delta x goes to 0, delta y divided by delta x. You put limit here. Then for this part you say dy by dx. And for this you say constant limit constant. Then derivative 1. Derivative is 1. dy over dx is 1. Y equal x graph. No, y equal x graph. When you consider the graph, here x axis, y axis, it is aligned with inclination 45. No? Then it has fixed gradient 1. Fixed gradient 1. Y equal x gradient. That's how we get derivative. Okay, first do that example. Do that one. Now see another example. Example 2. Consider y equal x square. Consider y equal x square. I'm going to find derivative here. Okay, y equal x squared. Okay, now you write previous statement. Write here statement. When let a small increment delta x given to x, then the corresponding increment y is delta y. Okay, then y plus delta y. So you put instead of x, x plus delta x. Here it is. Okay, you replace x by x plus delta x and y by y plus delta y. Now you subtract 2 minus 1. Y plus delta y minus y. Right side x plus delta x square minus x square. Simplify. Delta y, a binomial x square plus 2 times x times delta x plus delta x square minus x square. Here delta x means a single term. It is a single term. Then when finding derivative, we need ratio delta y over delta x. No? We need delta y over delta x. Now divide by delta x. Delta y over delta x. Then right side we get 2x and delta x only. You find that ratio delta y over delta x. Then finally you put limit. You put limit. Limit delta x goes to 0. Delta y over delta x equal limit delta x goes to 0. Here this relation 2x plus delta x. Then you say this one dy over dx, dy by dx. Then here delta x 0, here 0. The result will be 2x. Result will be 2x. Therefore, x square derivative 2x. X square derivative 2x. This technique little hard, okay, but we have direct technique to differentiate functions. But anyway, we have to practice this one. We have to practice this one. ඔයාලට exam එකේ මේක කොහෙවත් අහන්නේ නැහැ. term test වල අහන්න පුළුවන් මේක first principle එක. හැබැයි අපිට මේක directly differentiate කරන්න easy techniques තියෙනවා. හැබැයි මෙතන practice කරලා ඉන්න ඕනේ එතනට. Okay, do that example. අර කලින් ස්ටේට්මන්ට් එකට යන්න guys t කියලා දාලා ඉන්න එපා ස්ටේට්මන්ට් එක ලියන්න. මෙතන මේ delta x කියන එක තමයි variable එක වෙන්නේ. හරිද? x කියන එක නෙවෙයි දැන් variable එක limit එක ඇතුළට. මේ limit එක ඇතුලේ variable එක delta x. x නෙවෙයි. delta x 0. delta x 0 මෙතන 0 corresponding result 2x. Continue. That process, first principle method. First principle method. Okay. Say another example. Example 3. Y equal 2x plus 1. Then you have to write a statement here. Then y plus delta y, 2x plus delta x. Instead of x, you put x plus delta x. Then 2 minus 1. We get 2 minus 1 to subject delta y. Y plus delta y minus y, right side, 2x plus delta x plus 1 minus 2x plus 1. Delta y, here cancel 2x, 1, we have 2 delta x. Now divide by delta x. Now put limit. Limit delta x goes to 0, delta y over delta x, limit delta x goes to 0, 2. Then for this you say dy over dx, dy by dx. And here constant limit constant. Therefore, y equal 2x plus 1 derivative 2. Here see, y equal mx plus c, gradient 2, no? Then we get gradient 2. Gradient 2. Then anyway, you follow this process. Then you will obtain gradient, general gradient. Complete. Take time. Okay. So after that you try these questions by using first principles. Try them, result given here, derivatives I have given, but you try using first principles. We have direct technique to obtain this one, but for now you try using first principles. Take little time. Take little time. Okay, I'll do uh, x cube relation. Consider y equal x cube. Y plus delta y, x plus delta x cube. 2 minus 1, y plus delta y minus y, x plus delta x cube minus x cube minus x cube. Okay, then simplify. Delta y, here x plus delta x cube, 3x square times delta x, 3x times delta x square, delta x cube minus x cube. Always remember delta x single term. Okay, delta x times delta x times delta x squared. Delta x times x, we don't have any further simplification. Here you can't simplify. Yeah? X square times delta x, don't write delta x cube, it is wrong. Delta x single term. Now divide by delta x. Here this will be 3x square, 3x times delta x, here delta x squared. Now put limit. Delta x goes to 0, delta y over delta x, limit delta x goes to 0, 3x square, 3x times delta x squared. Now for this say dy over dx, dy by dx. Here 0, 0, then only 3x square come in. Okay, only 3x squared. Then x cube derivative 3x square. We have direct formats to differentiate these relations, but anyway, by using first principles, you have to practice it. Okay, then y equal 1 over x type. See this one, y equal 1 over x. Y equal 1 over x. Then you follow same procedure. Y plus delta y, 1 over x plus delta x. Instead of x, put x plus delta x. Then subtract. 2 minus 1, y plus delta y minus y, 1 over x plus delta x minus 1 over x. Here delta y. Get common denominator. Cross multiply. Then simplify. Minus delta x. Now divide by delta x. Here it is now. Now put limit. Delta x goes to 0. Delta y over delta x. Limit. Delta x goes to 0, minus 1 over x times x plus delta x. Now here say dy over dx. Say here minus 1 over x times x. Minus 1 over x squared. Okay. Don't miss steps. Write all steps one by one. අපි එනම් පොඩි රෙස්ට් එකක් ගමු. රෙස්ට් එකක් අරගෙන ඉතිරි කොටස් වලට යමු.